Hello, I'm Nate Marion, Business Development Manager for Smart Energy Products at RF Micro Devices. I'm here today with Eric Posey, Senior Design Engineer, and Gervais Seegers, Applications Engineer. We're going to demonstrate the performance of our ZigBee reference design comprised of the RF6525 and Ember EM357 ZigBee wireless networking system. RFMD teamed with Ember Corporation to introduce ZigBee front-end modules, FEMs, for smart grid applications that give utilities and consumers more control over how they monitor and save energy. ZigBee is a global wireless networking standard for monitoring and control in a variety of applications such as energy management, safety and security, lighting, and appliances. While RFMD's newest ZigBee FEMs can be used with any ZigBee application, the product family initially targets smart grid and smart energy applications such as smart meters, demand response, and home area network devices. Beyond smart energy, RFMD's ZigBee FEM family is also designed for industrial applications and any other wireless sensing and control applications that demand low power consumption, high performance, and proven reliability. I will now hand over the demonstration to Eric Posey, who will show the test setup and user interface.
My name is Eric Posey. I'm a design engineer in the WCBU business unit. I would like to show you the setup we have for our ZigBee demonstration. Here we have a dedicated radio for transmit. Antenna 2 is connected to the spectrum analyzer to demonstrate power, spectral mask, and harmonics. Antenna 1 is connected to a dedicated receive radio through an attenuator in which we will demonstrate receive sensitivity. Both radios will be controlled through a terminal emulation program that interfaces with Ember's node test firmware. I'd now like to introduce Gervais Seegers, who will be performing our ZigBee demonstration.
My name is Gervais Seegers. I'm the applications engineer supporting the RF6525. Today I'll be giving a demonstration showing the performance of the EM357 RF6525 radio board. And first I would like to go through the transmit parameters, and second the RX sensitivity performance. But first, before we go any further, just to give you a little insight of these boards, the EM357 6525 radio board is this board here, and it actually mates with the serial interface board, which comes in the Ember development kit. What we will demonstrate first is the spectral mask. The typical operating power for the radio board is 20 dBm, and as you can see here on our FSQ, we're at an operating power of 20 dBm, and you can see a true modulated ZigBee waveform. The first side lobe is actually 20 dB down from the peak, and the second side lobe is 30 dB down from the peak. This waveform shows that our RF6525 does not add any additional noise to the modulated waveform coming from the EM357 ZigBee wireless networking system. The next demonstration I would like to show you is our harmonic performance. First we will look at the second harmonic. So the second harmonic is illustrated here. We're at 4.89 gigahertz, which is the second harmonic of channel 19. And as you can see, we're well below minus 41.25 dBm per megahertz, which is the FCC standard. We're actually reading minus 48.75 dBm. Next, I would like to show you our third harmonic performance. We have a third harmonic of minus 43.62 dBm per megahertz, which once again gives us over 2 dB of margin from the FCC spec, which is minus 41.25. And finally, I would like to illustrate the fifth harmonic. So our fifth harmonic level is at minus 45 dBm per megahertz, which gives us greater than 3 dB margin from minus 41.25 dBm, which is the FCC spec. So the next test I would like to demonstrate is our RX sensitivity performance. And as you can see, we have two shielded boxes with our radio boards inside. This particular box here will have our transmitting part, and this box right here will be our receiving device. I'll be demonstrating a packet error rate of 1%, at a RX sensitivity level of -104 dBm or better. First, I would like to send 100 packets from our transmitting device in this box to our receiving device in this shielded box here at a RX sensitivity level of -100 dBm. So I've set our code to send 100 packets, and as you can see, this number right here indicates 100 packets were actually sent and received at a RX sensitivity level of -100 dBm. Lastly, I would like to demonstrate the receive sensitivity threshold of 1% PER at a sensitivity level of -107 dBm. As I increase the attenuation, I'm going to resend 100 packets. And as you can see, only 99 of those packets were received, showing a 1% PER at -107 dBm. For more information on the RF6525 EM357 radio board, please visit us at the following link. Thank you for watching.